Yeah, I was just in like Elizabeth Holmes trial space.
What?
Oh yeah,
What?
no,
What?
like a postmortem, not
What?
like actual
What?
live.
No. What? You were in a space about Elizabeth Holmes, and you did not invite me or think
You
of
know what?
me.
You know what? I did think of you. I did think of
You're
you,
making it
and
worse. That's making it worse. That's making it so much worse.
yeah, that's fair. You know what? That's fair. I figured you. I know. Here's actually the truth. It was not that interesting, and if it got
Here's
interesting,
actually
I
the
was
truth. That's how you're. Okay, here's actually the truth, is what you just said
okay.
before saying this.
I'm
As
gonna make
opposed
a
to like the
clap
lies that
here.
you've been saying up till now. I do. I mean, we gotta.
I'm clapping here so that I can see that this is the place to start the recording when I move this over to YouTube.
Oh no, no, no. We should. Um.
So I'll tell you what's actually the truth. No, I was on the space, and if it had gotten interesting, I was about to DM you, but it never got that interesting.
That's a crock of shit.
Actually, I'll tell you the one interesting thing.
That is the I was gonna pay for it of Twitter Spaces. I was gonna DM you if it got interesting. How was
Well,
it? How could it not have been interesting?
there were only like 8 people in the space, one journalist who was in the room, and the interesting anecdote was that when the trial started, it was totally circus in town. Couldn't get a seat. This guy, the journalist, was coming up from Santa Cruz like super early to get in line, and it's been nothing since all of the technical testimony started. But Elizabeth took the stand on Friday, so people started queuing up at midnight, I guess last night or this morning or whatever, like it was an iPhone launch. So he left his house in Santa Cruz at 4 a.m. and was like the 50th person in line.
This sounds extremely fascinating, and I feel that when you were hearing this, you were long past the point where you should have indicated to me that this was happening. I mean, I feel.
Now I know. Now,
I mean, I feel
now I
hurt.
know.
Honestly, I just feel hurt. I feel I'm really trying. I'm trying to process my emotion here, but I just feel. I mean, Elizabeth Holmes. Come on, it's catnip.
No, I know. I know.
I
It's fair.
cannot
It's fair.
look away.
It's fair. So the space also had a bunch of technical issues, so I was sitting on hold for like 20 minutes, but of course I pressed on.
You pressed on because, of course, it's all right. Well, all right. So I'm going to try to look past this, although it's going to be difficult.
Hey, how was your space yesterday, by the way?
Oh, that's what this is about. Here
No,
we
it's
are.
not.
Here we are. No, this is okay. They're here. That's what this is about. No, that's fine. Let's get it all out there. Look, someone on the internet invited me to come to their space. It was not a referendum on our space. Our space is still very special. It was not. I saw you dropping in and out of that space.
Yeah. I was dropping in and out because whatever. I had other stuff to attend to. I was like in the car.
Okay, are you sure you weren't dropping in and out just to draw attention to yourself? I mean, it was a little awkward, honestly. That's like, oh, Adam's here again, and Adam's left again. Adam's like,
No,
you deliberately storming out at different times in that space?
No, in full candor, as I mentioned, we're supporting this immigrant family from Afghanistan, and we had just dropped off a bike, but my own son had forgotten his pink bike helmet, so I needed to go back home to retrieve the pink bike helmet. It was that kind of emergency, and I was able to listen.
Which is those are the most dire emergencies, actually, because you've got
exactly.
you've got a very irrational boss at the other end of that emergency.
Absolutely. I mean, won't get over that one in the same way that you've gotten over this Elizabeth Holmes space so quickly.
Wow, this is really masterfully played. That
Thank you.
I think I ended up being a 4-year-old in this metaphor.
Thank you. Yeah.
Well, well, on that note, then I think have we processed all that? I feel like I feel better. Do you feel better?
Yeah, we'll pick it up next week. Yeah.
There we go. Okay. So that space was fun though, but the difference between my space and your space is you were in that space and I was in yours. But that's okay. Now I'm through it. Now I'm done. I'm ready to move on. So I mean, Thanksgiving has got to be your favorite holiday, right? Isn't Thanksgiving just the best holiday?
Yeah, especially now that I don't have to travel. Like, it's great.
Yes. Yeah, I think Thanksgiving is just a great holiday. It's just a good. I like it has meaning. I think I love its twin themes of family, obviously, but then also gratitude. Gratitude's great, and practicing gratitude is a very good thing to practice.
Yeah, I mean, and overeating. I mean, that's just to
and
mix that in there.
Yeah. Yeah, and I actually Google was bringing up. I've had photos online long enough now that I get these like, hey, on this day 14 years ago, and it will be, and on this day 14 years ago, Adam, you and I were having Thanksgiving together.
Really?
Yeah, in Noy
Huh.
Valley. Yeah,
All right. How about that?
it was like, and I gotta say, like, it was a bit of a ragtag bunch there. Definitely no one's family. It was a bunch of our. It was, but with my
All right. On this day.
now 17-year-old, then three. So it was fun anyway.
Awesome.
But I thought or we actually we thought that we might, in tech, we so frequently complain about everything for good reason, because lots of stuff merits complaints. But there's lots of little great stuff too, and I feel like we don't often we spend too much mental energy on the stuff that doesn't work, and not enough mental energy on the stuff that does work that we're really appreciative of. And I feel like there's a lot of that, a lot of like little stuff like that. And so Adam, as you and I were talking about this, we had to agree that there'd be no bag limit on dTollNet crates, on Rust dTollNet crates.
That's right. I mean, David Tolday, legend, and like it's impossible to do anything in Rust. I mean, literally anything in Rust because of absurdity, but like especially if you're writing macros or whatever. But anyway, I'm just in love with everything that guy does.
You know what I have you just like walked everything he's done? I've actually not done that, and I feel I should.
No, I feel like there's like a whole seminar series, like that one could do just examining his crates and his early works.
Yeah, I feel like we should be. I think you like listen to a track that's got an artist on it. Actually, do you say track, by the way, for?
Yeah, I say track.
Oh, that makes me feel so much better. My kids are just like abusing me over track, and then I'm saying record for album, which they also abuse me over. But I feel like that's fine, right? Anyway, whatever.
Yeah, that's fine. They're right to abuse you on that one.
Oh, drat. But you'll have like an artist that you'll hear on one track, and then you'll go like dig up their whole oeuvre. And go on that note, by the way, Loyal Carner. Have I told you?
No.
Oh man, Loyal Carner. Look this guy up. UK based, unbelievable, really, really good stuff. So I heard him on DJ. Anyway, this is reminding me that I should like with this. I basically heard Loyal Carner on one DJ Shadow track, and I'm like, I got to go figure out who this guy is and just listen to everything he's done, which is not very much because he's pretty young, but it's amazing stuff. But I feel like with dTollNet, I haven't done that, and I feel like we should. I feel like it should be just like walking every crate that guy has ever written.
It would be sort of a history of Rust as well, because I feel like so much of what he did was sort of just a step and a half ahead of what the community at large needed.
So on that note, do you want to kick it off? Like, what is a crate that you are? Wait, what do you think before Adam? Well, actually, I'll just open it up. It doesn't have to be.
Well, yeah. So I'll tell you what I'm thankful for, and this is not going to surprise you at all, Brian. And I've got a list of them, but where I'm going to start is something I've loved for a long time, Antler. Which is, you know that I love this.
I do know you love
generator.
Yeah.
But part of the reason why I love it so much, and I was reminded of this recently, is I went back into the dtrace parser in Lexer in Lex and Yak. They're so fucking hard to write and so fucking hard to understand.
Yeah.
And Antler, and then more recently, I've been using this crate called Pest in Rust, which different in construction but similar in concept, which is, let me just write the grammar and get out of my way about all these rules and reduce rules and so forth, and just kind of do what I say. And both of these are magical in that regard. Like it turns writing lexers and parsers from what I feel like is almost witchcraft into something that is like so easy that there's no excuse not to have a DSL where you need one.
That is, an Antler, it should be said, is missing an E.
Yes. ANTLR.
ATLR.
And it's mostly in the Java world, but like, there's like a Rust port ongoing and stuff to other different languages. But it's great, and if you need a parser, like it's so easy to write something in.
And then is Pest derived from Antler? Or
no, totally different. And I wish I could remember the acronym off the top of my head, but it's it's a different type of parser. Like I'm not a compiler or parser nerd, so I don't understand the taxonomy sufficiently. But like there's some kinds of grammars you could or could not do in one or the other. But similar, at least from my dumb guy perspective, of like I want a simple DSL, and it lets me do it pretty simply in Rust.
Well, and I think it's interesting that in terms of like, you said there's no excuse for not using a DSL. And because I think we need to reach to DSLs probably more frequently, and the ability to create them pleasurably will make that much easier to go do.
Yeah, absolutely. Like rather than retrofitting some configuration language on something that's sort of close enough, or relying on consumers to like sort of get it right and decipher obscure error messages. Yeah, like you can drop in a DSL without that much trouble using one of these tools.
Yeah, that's interesting. I need to. I've not done that, and I need to. Have you been using them recently, or?
So we used. I haven't used Antler in Rust, but I used Pest when Ben and I worked on the USDT crate for Rust. So the ability to drop dtrace userland static probes into Rust code, and in order to parse the dtrace provider format, we built a little parser using Pest.
Yeah, that is so neat, and that's a great use case for it too, because you made it much easier to use by being able to build in a little parser there.
Yeah, totally.
That's cool. Yeah.
How about you? What's top of the list for you?
I've got some big things, some small things. Not all Rust related, but definitely a lot that are Rust related, just because we're doing a lot of Rust work. So BuildRS is something that have you done anything with BuildRS at all?
I've written some BuildRS scripts. Like I've been in a weird phase of writing code generators, and the code generators I've been writing in Rust can be used either in BuildRS or as a macro. The macro form being sort of easier when it works, and the BuildRS form being nicer when it doesn't.
Right. So BuildRS is basically proc macros, but taken to the logical extreme of just like, why don't you just like write a program to write your program? And I just found it's proc macros are great, but they can be, as you said, I think you phrased it very concisely. It's like it's great when once they work, they're amazing. They can be a little hard to get working, not be any slight on proc macros. I mean, the development environment is honestly great. It's just that it's in this like weird layer where you are running your code as part of compiling the code effectively, and you're in this different context.
Yeah, I mean, I have this proc macro I wrote recently that's like 6,000 or 8,000 lines of code.
Oh, Jesus.
So like when it fails, it's like, yeah, there's a problem somewhere in this proc macro invocation. You're like, okay, well, can you give me a hint? It's like,
no. I thought that you were going to say 6 or 8, not 6 or 8,000.
No.
Maybe 6 or 800.
This is a proc macro that takes in JSON schema and poops out Rust types.
Ooh. Okay, so that's the kind of thing that I've been using BuildRS for, where you are this whole idea that I really like of like, I'm going to take in data that's in this format, and I'm going to generate Rust code from that data, and then you're going to and then obviously write a program again. I think that this is a theme that's come up for a couple different times for us in a couple different ways, and BuildRS is great. I just think it's like one of those things that we don't talk about enough. I think it's broadly, just for those who don't have context of BuildRS, it's pretty straightforward. It basically is a program that will be compiled and run before you compile your program. So you can generate effectively arbitrary code, and you can do it. I would say, more cleanly than you're in an environment that's a little easier to debug than your 6,000 to 8,000 lines of proc macro.
Yes, totally.
So I'd say that's top of the recent list. I'm very
okay. So I have a challenge for you for the next 30, 45 minutes or whatever. Think if there is a piece of proprietary software, Brian, that you are thankful for.
Yes.
Oh, you already got that top of mind?
Well, okay. I've got one of them top of mind because I use it as the example that I don't actually dislike all proprietary software. It's just the broken proprietary software, which is most of it. So
Okay.
the I now they're re-implementing this, but the Salier is the and actually this is a good one to talk about because the Salier makes a logic analyzer, and the it's kind of a generational thing, I guess, because there are people who think a Salier is unconscionably expensive because I mean you're spending $400 for a logic analyzer. I am definitely of the school that's like, yeah, these things were like $10,000 when I was an undergraduate. So I think it's a miracle that I've got a logic analyzer for $400. And yes, it's limited. It's not a high speed logic analyzer, but it can go up to like 100 megahertz pretty easily. And that software is historically proprietary. I think they are actually trying to do it. They're trying to make it open in their more recent version, and it's pretty good. I like it. So, but
Yeah, I mean, it's great.
do you have an example in mind of proprietary software that you like?
I do. I
Was this a
wanted to
trick?
kick. I want to open it up, so it's just not the But let me get back to that.
Yeah.
But I do. But I was hoping on this that we might get folks raising their hand
Yes, definitely.
and talking about what they're thankful for, what pieces of software they're thankful for. And to be clear, I have like a whole page of stuff if we don't get a lot of hands raised.
But Ian,
But
Ian, I saw
yeah, go
you,
ahead.
you were. Matt, actually, don't mind. I'm gonna let Ian. If you got something you wanted to. Or,
Yeah, the thing that was kind of front of mind for me was my YubiKey.
ooh, yeah.
As a professional working within a large company that has a single sign-on implementation that does not sign me on via once, but it's not a thing where you sign on once and you're signed in everywhere. It's more that every time you sign in through the same thing. The YubiKey saves me, quite a lot of time in my day and quite a lot of hassle of not having to pull out my phone and find the app and press the button and all that kind of stuff. It just saves me so much time, and I love it.
Adam, have you used YubiKey before? Have you seen these things?
I have, yeah. And I feel fortunate to like never have worked at a company that had such strict security that I needed one. But when we were at Sun and briefly at Oracle, there was that little like sort of credit card sized
God.
like OTP goober.
So
Yeah, that was
What the-
such a
that-
pain in the neck.
that was so weird. That
So
thing.
like I've kind of kicked the tires on YubiKey, and man, it
YubiKey is great.
so much better.
Yeah, it's way better. And Ian, have you had to use other like alternatives in the past of these kind of like goofy physical challenges?
I hadn't used any of the physical ones. I had used the Duo mobile app a lot, where it would send me a push notification, and I would click on the notification, and I have to click a button in an app. But that meant, always having my phone on hand and not in my pocket, and it was a lot more hassle than just pressing this little button on this tiny little USB 3 dongle that's sitting in my Mac Mini.
Well, and I feel that like it's always such a hassle to deal with security that we often we like the best it can possibly do is be a minimal hassle. So I think it is great to call out something that's actually like doing a really pretty good job minimizing the hassle.
Yeah, and it's also like available
Right.
to everyone, right? It's not just this proprietary thing that's only inside one company. Everyone can get YubiKeys, and it's a kind of open API, so people can support the standard in their own applications.
Yeah, absolutely. That's a good one. Matt, what are you thankful for?
Right. So I'm thankful for open source and for being able to actually reuse libraries in not only in Rust but in a lot of modern languages in general. And I'm going to illustrate that with two anecdotes, one negative and one positive. You guys, first the negative one. You guys were talking about Antler and not having any excuse to not do a DSL. And I experienced the opposite of that when I was working on a C++ project in 2003. This was a Windows app. I was doing some contract work on a Windows application. It was written in C++ using Visual C++, and I had gotten to a feature where I thought it would be useful to be able to define a DSL, and I even looked at Antler, which I think had a C++ version, but it was just going to be so much trouble to add that dependency to the project that I was like, no, well, I'll just use XML. It's already in here.
Oh man,
you know how that goes.
Yeah. Right.
Yeah. Conversely, on.
Oh, Matt, you muted yourself. Or did I accidentally?
There we go.
Yep.
There we go. Yeah. Conversely, on the positive side, I had one particular example in mind of a set of open source libraries that were really helpful to me at a key point in my career. So in 2004, I was and this could serve as a teaser for my accessibility history part 2 that I want to do sometime. But I was looking into starting to develop a screen reader for Windows, and Windows programming used to really intimidate me because the Win32 API is so huge, and I hadn't really gotten my head around COM and so forth. But and I didn't really know much at that time about how Windows screen readers worked. But there was a group there was a research group at the University of North Carolina, Chapel Hill, in their CS department that had put out a handful of Python libraries for working with the Windows accessibility API at the time, and installing the keyboard hooks that you needed to intercept keystrokes, because that's something that a screen reader needs to do, and for working with the Microsoft Speech API. And so these libraries together helped me get started prototyping, and I'm just thankful that this group chose to open source libraries that they were developing as part of their research projects.
Yeah, and it's kind of unfortunate that it can be hard to, and maybe in this case that group was aware that you were using it, but I think so often you throw stuff out there and people complain when it breaks.
I let them know.
Yeah, I'm sure they appreciate it.
I let them know, and I email. I mean, my email was part thanks and part promotion of my product, but I did let them know.
Yeah, that's great. And I mean, the older I get, the more I appreciate how deep and profound open source is. I mean, it really is I think it is a more profound revolution in our lifetimes and arguably even the internet when it comes to software construction, software engineering. So that's definitely an evergreen.
Well, and I also emailed the professor again much later, a few years ago, just because I was thinking back and thinking about how helpful that was for me getting started in something that turned out to be pretty important in my career. And that was a more pure thank you email. So
yeah, those are great. I think that whenever you can hear from someone that you managed to influence at an important time, I think that's really gratifying to hear. So that's terrific. All right, who's next? Go for it.
Did we have Fester joined?
Yeah, I'm here. Hi.
Hi,
and this is going to sound a little bit of brown. It's going to sound like a little bit of brown nosing, but honestly, Node.js. It was the first. No, seriously, I mean, by trade, I'm pretty much a .NET developer, right? I spend most of my time in C#, but the thing is that whenever I opened my first company, my second company, and I tried to make a video game, I was able to develop the entire thing in the same language from front end to back end. You know how rare of a situation that is to be able to write things, every layer in the same language. And this was probably 10 years ago. So it does sound like it, but I still use it to this day in tooling. Nothing is running off of it permanently, but it really does help my day to day a lot. And I guess by proxy, JavaScript itself, though, I agree with you, Brian. TypeScript is a godsend. It's much better than it, but I had to say it.
No,
It's true. The software
No,
is very
that's a good
useful.
one. And honestly, like I think my own relationship with Node is so complicated that it's great to be reminded about its that fundamental value, that basic value in being able to use JavaScript on the server side is still, and I can see Matt Ranney is here, and I remember Matt back in the day when we were talking about what's compelling about Node. And I had a bunch of kind of arguments that I thought were compelling about Node. And Matt's like, you're overthinking it. It's just JavaScript on the server, man. Like that's what makes it compelling, is that it's JavaScript, and that there's value in having the same language on both the front end and the back end.
And database. I was MongoDB, so I mean all of it. But I mean, granted, yeah, it's the much better if you're going to learn C or something like that and make something much more performant. But one can't argue with saying I'm thankful for something that helps me make money.
There you go. So that's a good one.
You know.
That's a good one. Yeah, thank you for that.
Yeah, Patrick?
Yeah, I just wanted to throw out RabbitMQ. I think a lot of people don't enjoy working with it because it can, kind of get into some weird situations. But I don't think I've seen another piece of software besides like Kafka just turn a whole machine into something that makes sense. It's like, oh yes, that box is now a queue. It's almost like Redis turning a box or into a cache. And it's just so easy to think about, and it ships with a really, really nice little web UI, so that I've actually taught people how to use RabbitMQ, like by showing them the web UI, creating queues, showing them like the different ways that you can subscribe to different topics. And I just think it's a great system, and I think that whole it's evolved over the years, and AMQP 092 has been around for such a long time, and so stable that like even if you're working with a language that's super old, it probably implements it correctly. I just think it's a great system.
And so, and what version of Rabbit are you? So, because I've not kept up with Rabbit, I think since like 2.7. Does that even? I mean, the version strings are all mashed together in my head. But I mean, are you running? So you continue to run Rabbit? You running Rabbit today, or keeping up with releases of Rabbit?
Yeah, well, so actually, no, we're running actually a pretty old version in production right now. As things happen, we just haven't had the need to upgrade it. It's been relatively stable.
Well, that tells you something right there, right? The fact that you haven't had the need to upgrade it because it's worked for you.
Yeah, no, it's just I get sad when people get mad at it because they're like, oh, Rabbit's backed up again, and it's like Rabbit is the noun in that sentence that is the frustrations directed at, but really it's like some other piece of the system is not doing its job. So I always point out how great it is.
That's awesome. That's great.
Yeah,
if folks want to like stick up their hands with the little emoji icon or whatever, yeah, Nam, do you want to jump in?
Sure. Can you hear me?
Yep.
Yeah.
Perfect. Yeah. So you guys are asking about open source versus closed source or proprietary, and I have one that crosses both. So the combination of WireGuard and Tailscale has been really pleasant to work with. Being able to have like WireGuard mesh between all different machines without having to think really hard about it, and the fact that it's open source, everything except the server side, for which there's like an open source like alternative that someone has written. It's been I've even gotten a port of it working on Illumos machines that I'm still working very, very slowly on upstreaming, but it makes networking very, very nice again. You can like put a service on a Tailscale IP address and not have to put any like authentication or protection on it, and things just work. It's like the internet of the old days before we had to start worrying about security.
Yeah, that's great. I've heard great things about Tailscale, and I have not really like used it directly. But I mean, I know we use it at Oxide, right?
That's true. We don't just have. We're so secure. We have 2 VPNs.
Right. We're definitely secure.
That's right.
But and have you dealt with it directly, Adam?
I mean, I've used our Tailscale incarnation. I have actually debugged an issue with it with using dtrace, and then got an immediate response on Twitter, and they were super helpful. So yeah, I've used it a little, and the team behind it is great.
Okay, but isn't that? I think you should be. Everyone should be so lucky as to have to debug exactly one issue with every technology they use, as this kind of, because you end up with this other kind of test of like how is the community? How do they deal with new information or about something that is not functioning correctly? And I always find that that's very revealing.
Oh, totally. Yeah. And in this case, I saw that it was like forking and executing a process once every 200 milliseconds, which, felt like
a lot.
Frequently.
Probably more than it needs to be. Yeah.
Given that I wasn't even using the VPN at the moment.
Right, exactly.
And they came back right away, and they both apologized, and they were like, well, you're using the old version. Here's the new version. So they got me sorted out really quickly.
That's great. Yeah.
Yeah, further to their credit, when I started playing around with porting it to Illumos, and I got, based on like Josh Clulow's old port of WireGuard Go, they were super helpful in getting me like to the point where we are now, where it works really, really well. And I'm sure that if I actually get WireGuard Go fully upstreamed, that they will be very happy to like help us get it fully upstreamed for Illumos on the Tailscale side, which I don't know, based on my rate of progress on it as a side project, it'll probably take another couple of years, but we'll get there eventually.
Yeah, that's great. That's great. Well, yeah, no, that's a good one. And definitely, I mean, I also feel like there's something to be said for like a community or a technology that is welcoming of different platforms. And clearly, coming from the Illumos side, we get a lot of exposure to this where, I mean, like when we finished the port to Go, I mean, Adam, I think I've told you this, that when we ported Go to Illumos, and they created the notion of a first-class port so they could exclude the port that we had just completed. Yeah, it's like, wait a minute, the first-class port seems to include every port except for okay, I get it. All right, yeah, all right.
I see what you're telling us.
I understand. Yeah, Jason, go for it.
Yeah, I'd really like to express my thanks back in the closed source days with Solaris as a sysadmin for Truss, because and the kernel infrastructure that actually supported that. I give you the worst truss or the best truss that I ever did was trussing XDM starting up 100 virtual Sunray X servers, because we'd gone and bought a bundle of 100 Sunray clients and a server, and they were locking up. Some subset of them were just locking up for minutes on end after people logged out, and we had really full labs, and it was kind of my advocacy that got the Sunrays in there, so I was kind of packing death about it. But yeah, no, S-tracing XDM starting up 100 virtual X servers and just sending it all to an enormous file that I could trawl through later. I worked out what the weird error messages were that XDM was putting out, and it turned out that every time you did an XDMCP indirect query, you remember the old X-terminal chooser, which let you choose it from a bunch of different hosts?
Right, yeah.
So when you did that, that wasn't apparently the usage case that the Sunray people were expecting, and they forgot that X-terminal, virtual X-terminal server was actually allocated and existed, and so they try and reuse that virtual server number. And XDM, basically, I had to infer, because I didn't have the source at this point that I could go and look at, I had to infer that XDM was basically sitting in a big event loop checking for all of the virtual X servers, and well, the X servers, and whether they'd died, and basically getting new sessions started on each one. And it would sit there and try and repeat. It would basically rerun trying to open up this virtual X server on a particular server number for a minute, and then it would go on to the next. Then it would go on to the next thing in its list. But we had a whole lab of people who were used to that chooser way of getting to their host, and that meant that we had 20 of these things scattered into 100 hosts, and that was like 20 minutes or more that a particular terminal could sit there stalled because XGM just wouldn't come around and say, "Oh, you need a new session, set up for you."
Oh man, and trust is what helped you crack that case.
Yeah, so I was kind of Mr. Truss at that point, and then became Mr. S-Trace under Linux. And Truss, for instance, someone said to me, "Hey, why do I get syntax errors when I compile this code using Sun-C on SAMFS?" And I was like, "That's interesting." And so I trust that, and in like 5 minutes, I can see that it's mapping the code to, and looking for a null byte at the end of the code as a sentinel in the compiler rather than doing reads for the source. And that SAMFS had a bug where their mmap didn't actually clear out the last page of the mmap. And so, you just got gibberish on the end of your source file seen by Sun-C when you tried to compile on SAMFS. So
that's great.
Yeah. So for those who are unaware about it, so TRUSS stands for Trace System Calls and Signals. And this was developed by the late Roger Faulkner, and it is certainly similar in spirit to S-Trace, but Roger had a very strong feelings about the need for TRUSS to be entirely robust. So in terms of being able to follow threads and not leaving processes in terrible states, and there were all sorts of stories about the unholy things that Roger did to get TRUSS actually working properly.
So Brian, I referred a colleague to TRUSS like on Friday, and for an obscure use case, which is that TRUSS, to my knowledge, in the Illumos source base is the only place that records actually all system calls and subsystem calls, because for some reason some of the system calls were not deemed important enough to have their own number, but instead have to be subcodes off of some other number. I think because of some history of wanting the system call number to be a single byte long. Anyway, TRUSS is the only place I know that has like a single file that describes every system call, all the subcodes, and all the arguments.
In terms of the source code, yeah, interesting. And it's only obviously, the things you can do with TRUSS, you can definitely do with dtrace, and dtrace is designed to do it without actually stopping the target process. But TRUSS remains a very robust and important little program. Yeah, Jason, that was great. Let's see, who's next? Simeon, did you want to? Oh yeah, Rahul, go ahead.
Yeah, so it's interesting. As you guys started this, I was like, oh, what am I thankful for? And I went back and I was like, oh, Linux, or maybe my editor, my IDE, Emacs, or something else, or the compiler, the GCC, or something. And then I went back to the very beginning of when I started learning about computers, and I think what I'm most thankful for is the Linux documentation project, so tldp.org.
Oh yeah, interesting. Yeah.
And back in the day, for me as someone who had my first computer and didn't really have, wasn't online, wasn't able to get online, but just being able to read, okay, the networking how to, and be able to understand, okay, this is what networking is all about. I think I'm most thankful for that, like for everything that followed in my, in my professional career, and this was at that point onwards. So
yeah,
I guess
that's great. I mean, 'cause I think that, and I feel that and this is probably true of any project, but I think that there is a very small number of people who've done an outsized amount of the documentation, certainly like the Linux documentation project, and there's so many of the Linux man pages that are basically due to one individual. I'm trying to pull up the name. This is someone who spent a lot of time in the Linux man pages. The documentation is really really important, and it's something that Rahul, for the reasons you're talking about, right, in terms of getting people introduced into the system, and it's easy to forget that documentation or the importance of it, because we become users of the system and we forget what it's like to walk up to it afresh.
The thing that's interesting to me is that it's a change in culture in terms of what's happening today, and maybe it's just because where I am, but so one of the questions that kind of constantly I keep thinking about is, how do people gain new knowledge about, and I'll just talk about system stuff because that's what I am most familiar with. And it's interesting, you search for anything online, and for a lot of the core information, there is a man page or a TLDP page that's still out there that has the kind of the best signal to noise ratio and what you want to know about, but it's never really it doesn't really surface on a web search.
Yeah, right. I know what you mean. It's like you end up hitting like some Stack Overflow or right.
Exactly.
And yeah, I feel the same way. I have to say, I find that because the Rust documentation I think is by and large very good, but I am too used to googling answers to questions, and it's actually not the best way to search. Often, you're right, Rahul. You actually want to go to the doc, go read the docs, which Google doesn't necessarily guide you to do.
And I guess it's a different way of working, because you find the answer and then you move past this. You'll find the answer and you'll move past that point, and it's all in the okay. Next problem, and that's fine once you're kind of familiar with the basics. But I wonder how newbies kind of how the learning process has kind of changed for that. But anyway, that's what I'm thankful for. So
yeah, that's a great one, and I think documentation in general, and especially those kind of long form narratives. That I would say that just to pitch it, the Programming in Rust book, I think is a great introduction to Rust. That it has a very, it's not just the documentation of the system, but an actual narrative that takes you through it, which I think is actually very important. Simeon, did you have a?
Yeah, I was actually thinking about what you said about your expectations about logic analyzers. I don't know if you've seen those $5 clones of the original Salier logic analyzer that runs to like 24 megahertz or something like that.
Yeah.
So
I have one. Yeah.
Yeah, I had one of those, and Edwin and I were trying to do something with SPI running at about, I don't know, probably 20 megahertz, and it finally sort of stopped working. Like the $5, I had used up the $5 worth of value for that. So I ended up getting the DS Logic Plus, which I've been very happy with. But to get back to software, I'm grateful for is I've been able to use the same software with both, and in fact, so I'm talking about SIGROC. It's a GUI tool called PulseView, and I've been able to use it with my scope, with my multimeter, and it just works great.
It does work, and actually, it was clutch for me to be able to figure out. There's ARM has this thing called ETM, Embedded Trace Macro Cell, and unfortunately, it has kind of fallen by the wayside in more recent CPUs, but it allows you to trace every instruction. And there's a pretty complicated protocol to actually interpret it. And it was the SIGROC plugin, Simeon, that's how I was able to finally figure out what this thing was expecting, because the documentation was left something to be desired. It was great. Thank God. This is like one of these things where you're in like a protocol analyzer or whatever, and something that's open source, and you're like, whoever you are, nameless person who has broken this trail, thank you so much. You are saving me so much time.
And while I have the floor, I'll get my David Tolnay crate contribution in there. I'd say this error and anyhow.
Yes.
Someone coming to Rust from Go, where error handling is very painful. It just makes a lot of sense. So that's what I'm grateful for.
Oh, amen. I'm such a this error and anyhow convert. It is so great.
Yes, I mean, I'm really glad you mentioned, I mean, obviously the David Tolnay crates, but also PulseView, like also on my list. Like my first introduction to logic analyzers and oscilloscopes, like that I could just do on my dining room table. And I'm a cheapskate, so I didn't buy myself a Salei. And then Brian, to your point, this is sort of a thankless task. I mean, business related, but clearly born from a community with a lot of passion. And I got a couple others that I wanted to mention along those lines to grab the mic back.
Yeah,
but
definitely.
one is, and I was thinking about this because what are these pieces that I use every day? One of them is QMK, which is open source software for keyboard controllers. And
QMK.
QMK, yeah. So this is software I'm running on my keyboard. So every character I type is going through QMK. And it lets you like remap keys, and I've got LEDs because it's that kind of keyboard. It lets you program them to strobe in different ways and stuff. Very cool. And again, just this beautiful community that like has built this up and make it work for a bunch of controllers and so forth. And the other one that I use every day is on my camera at the other side of my computer, which is a thing that you talked to Trammell Hudson about, Brian. Magic Lantern. And this is fucking incredible, right? This takes this proprietary software on Canon cameras, and it's not exactly a firmware hack, but wedges its own code. You jam it onto a data card, stick it into your camera, and all of a sudden your camera can do all this magical stuff, including like execute a bunch of like your own handwritten code if you wanted, but have very fine-grained control over your camera. And again, like you have people who are just, there's no business associated with this. There's people passionately porting this to new cameras left and right. It's very cool.
It's amazing. Trammell is the gutsiest person on the planet. I feel it's like to take this very expensive camera and be like, and now I'm going to load my own firmware on it. You're like, okay, wow.
Yeah.
It's amazing. And if people haven't listened to Trammell, Trammell is someone, again, that you just like go consume everything he's ever produced. It's all so incredible. Really, really interesting stuff.
Yeah, he's an amazing person in terms of being able to start these projects, get them to a level of sufficiency, but then enable a community to sort of pass the baton. Which I think is a missing step in so many projects.
Yeah, he's like a Johnny Appleseed of open firmware. He like goes from place to place, like cracking these things open and then kind of moving on to the next town. And that's the way he likes to operate, and he's extremely effective.
Yeah.
Matt, I saw you getting in here.
Hi, I assume you mean me.
Yeah. Hi.
Yeah, hey, man. Hey, what's up?
How are you?
So I just want to, good, man. I want to echo all the open source. I mean, obviously amazing, right? Like open source, the best, revolutionary change, etc. But for me, the thing that I've been most thankful for in software, which is what I work on in the last year, has been eBPF. It's actually gotten me excited about like writing software again. The possibilities it unlocks, like I feel like just somehow it was like the last little bit of push that I needed to kind of like get how the entire computer I could like program.
And so, Matt, are you using eBPF to like understand what the system is doing, or actually modify its behavior?
So understand first, but I have grand designs on modifying its behavior. Yeah, I mean that's right. I mean it's much harder, or I don't know. I would say it's different if you want to start modifying its behavior. But that the fact that you could use it for that was just so surprising to me that I spent time on it. And it's really interesting.
That's great. Yeah, I have. They definitely. It's got obviously a different approach. Because with dtrace, we definitely have always believed in not allowing people to arbitrarily modify the system's behavior, which I think has got strengths but also weaknesses. And it's great that people are using eBPF to do kind of arbitrary things easily. So, and are you actually? I mean, I guess. like what kinds of things would you implement in eBPF?
Right. So, I mean, what I personally am doing with it is I have a fleet-wide monitoring agent that's kind of like watching for various things that are interesting to us and like kind of putting it into a data stream that can be indexed and, aggregated, queried by people. It's like, you made this TCP request, you made this HTTP request. You're doing these various things that are interesting, and we kind of aggregate them so people can find out what's happening, sort of from the bottoms up.
Right. Okay. So you are really using it as kind of arbitrary observability, which is great.
Yeah, but basically like low level. So there's like the top down, which is like open telemetry and explicit instrumentation, and this is like coming at it from the other direction.
Yeah, there's nothing beats the bottom up in terms of like what's actually happening on the system.
Yeah, I mean, it's been just enlightening to sort of see how things work, and like, look, I love dtrace. It like opened my eyes to like kind of what's possible in terms of changing code that runs in kernel space like safely at runtime. I mean, that was amazing. Sadly, I don't use any systems that like have access to it.
I think it's honestly I think it's great that there are. I mean, and I don't know to what degree dtrace kind of directly informed eBPF or not, but I think it's observability is great and it's important, and I welcome observability and debuggability. I welcome in all of their forms. So I am glad that I think it's great that it's so useful. It's good so we can figure out what the hell these systems are doing. We should.
Yeah, and I would say the one thing that's been particularly satisfying for me is seeing some junior engineers kind of see this work that I'm doing with eBPF and like really kind of grabbing onto it and saying like, "Whoa, how did you do that? Like that's super interesting. Like how can I learn more about that? Like what?" Well, this is such a novel, kind of way of coming at this problem. Like, I never would even thought of it, and like getting people excited about that, like I just think is super cool.
Yeah, that's good.
Yeah, when you're turning a new lens on a system like that, where you're able to look at these data that were previously either impossible to see or impossible to make sense of, and then extracting the actual behavior in your own code that's creating that. I mean, it's unbelievable to folks who maybe have never seen that kind of lens before or had access to those kinds of data before.
Yeah, super good.
Well, and getting people over their own hump of, I think that one of the challenges we've always had with dtrace is that it's there's a big difference between kind of looking at someone else do it and learning how to do it yourself and having it kind of bail your own butt out. And I'm sure that the same is true of eBPF or any observability or debugging tool. It's like, how do you facilitate getting people, and how do you facilitate those junior engineers, Matt, getting kind of, excited about it to the point that they're digging in and getting kind of over the hump and realizing that like, yeah, you can answer these questions. You can go gather the data. We don't have to guess anymore. We can actually go figure out what's actually happening.
I mean, I had experience like a couple of days ago or like late last week. A different engineer that I worked with before came to me and said, "Hey, I heard you're doing this thing. Like, I got a PR for you, but I'm not sure if you're into it. But like, I think I can solve this other problem we have." And he'd like, written the C code, and he's like, I'm not sure if it's any good, but like, here's what I got, and it was awesome. It was so good.
That's great.
That's cool.
And Adam, have you met Matt? Did you know one another?
No, I don't think so.
Okay, so Matt is Matt I've known since early Node days, and in particular, Matt helped really inspire Dave's work on all the postmortem work we did with JavaScript on Node, because Matt in particular had an app that was like suffering from, that was leaking memory over time, right? Even though it's GC, it's just like the object graph's getting bigger and bigger. He's having to reset this thing, and Matt's just like, can't we just like figure out what this memory is? Like, why can't we figure that out? And I'm like, why can't we figure that out? So, Matt, I'm always very grateful for you for just kind of like just asking these kind of like the basic questions are really important, and like there's often a lot of really complicated implementation to answer those basic questions, but we should ask them.
Totally. Adam, I think I said hi to you one time at a joint meetup, but
Sorry, Matt.
I'm sure it was not so memorable.
You know, and I know it was extremely awkward, and I really wanted to use this to clear the air, and it just didn't work out. This is really backfiring. I had this I'm like, I need to get them together if they can, but no, I'm sorry, this really went sideways. Well, you know,
in a hurry, yeah.
It's all good.
All right, we've got a couple more minutes. I know some folks have haven't. Matt Sy, go chime in.
Yeah, I mean, I've probably got my top three here. In no particular order would be CUDA, Ethernet, and GPS. I don't know which one you want to take first.
Ooh, yeah. Let's talk. CUDA. Let's start with CUDA's super important, I feel. Yeah, start with that.
Yeah, I mean, CUDA is like the first, and I might argue the only non-traditional computational language that's actually gotten something right. Like they've really got the abstraction just like absolutely nailed in terms of how you'd want to implement this like kind of VLIW, but not really kind of architecture that you encounter on a GPU. Like it is, despite being proprietary, they've just nailed the usability.
Yeah, no, it's definitely important. And in what capacity do you use it? Are you using it for like MLDL, or are you using it as a GPU for scientific computation, or for graphics, or how do you actually use it?
GPU, mostly scientific computation type stuff. It's, like in terms of implementing arbitrary algorithms, it's the one thing that I've encountered that's, like there's a lot of places where like, oh yeah, okay, fine, it runs TensorFlow, but like actually, or like it runs VHDL on the side of an FPGA to the extent that an FPGA quote unquote runs anything. Like CUDA hits that really nice middle ground between being understandable as software, where like, oh, VHDL, you have timing analysis, and like try explaining to someone that like, well, you didn't need timing, so like you just get random data.
Yeah.
Instead of like you just get the data slow, right? But like CUDA still hits that point where like you can write bad code and have it work okay, and like be understandable to mere mortals. But like it's also really able to leverage that parallel architecture of the hardware in a way that's just beautiful.
Well, and to our discussion a couple weeks ago, I mean, that's what happened to supercomputing, right? I mean, that is modern supercomputing, effectively. I mean, Matt, I'd love to get your take on that, but that's what it feels like happened to supercomputing.
Yeah, I mean, pretty much. You can make the OpenGL argument. I'm more of a CUDA guy, but like, or OpenCL rather. But yeah, I mean, those are supercomputers, right? I mean, like just core count per silicon density, instruction set complexity is low. Like it's everything that you'd ever wanted, right?
And not to go kind of kubectl versus kubectl on you, but I notice you're saying CUDA, and I've been saying CUDA. I think have I been mispronouncing it? Can we just get this out there?
Me too. I'm the same kind of idiot if that's the wrong way.
I always thought it was CUDA. I mean,
we're going to go with you. You're I think
the person who's actually used it.
The person who's actually used it.
Like might be like an East Coast, West Coast,
I've been to
like
meetings
California
at NVIDIA, and they say CUDA.
They say CUDA. Okay.
They say CUDA in the NVIDIA headquarters, which is shaped like a triangle.
Okay, I have never had anyone from NVIDIA correct me. So, like, what? 50-50.
There you go.
There we go.
Yeah.
All right, and then you got so that however you pronounce it, that's a great and an important contribution. And then all right, so you also had Ethernet.
Yeah. Just absolutely phenomenal. Anywhere from 10 megabits per second to 800 gigabits per second, it all interoperates pretty damn near seamlessly. Like,
it's good. I mean,
if there is such a thing as a universal protocol, that is it.
I'm thankful for Ethernet for sure.
Yes, especially wired Ethernet.
Yeah, tell me about it.
Right. And then Matt, I think you had a third one in there, right?
Yeah, GPS.
GPS, yes. Yeah, that's a big deal, isn't it? The whole GPS thing.
I mean, Brian, I mean, since you're an oldster too, like, I mean, I have an old car. I have a 20-year-old car, and it has 20 years worth of accumulated maps in it. Have you ever explained like a map to a child?
Like a
That, like,
like a paper map.
Yeah, like that you would take out a map and find where you wanted to go on that map, and then use that map to navigate streets. Like it makes me feel like I'm a billion years old when I explain
you just sound absolutely crazy. I mean, it just
Right.
sounds like
like you used paper to get places. Walk me through that.
And the fact that you would have and then you'd often it's like very actually, it's very hard to drive and navigate at the same time. So yeah, no, you sound bonkers when you describe that stuff. No, GPS. Yeah. And it is amazing how ubiquitous GPS has become, and how low power. And yeah, sorry, Matt, go ahead.
And like, I was not even thinking the navigation component. In that, like, that's definitely like its nominal purpose and very cool. But like, GPS is, when you get into the technical details of it, it is as close to a universal planetary reference frame in the relativistic sense as you can get. In that, like, you now have a basically internationally, like a whole global reference about timing and frequency, so that you can do things like Google Spanner being like the most open example of that, where like you now have a common time reference for the entire planet.
So you really thinking of it more in terms of synchronized time than anything else? Yeah, interesting.
I mean, just in terms of like being the complete miracle of general relativity. Like, I can navigate on road signs, but like if you want me to like not have to break out graduate level physics textbooks to synchronize two clocks on opposite sides of the Atlantic Ocean, like, the GPS disciplined oscillators are basically the most precise frequency references we have, short of the references that sync the GPS system. And like getting to do things like Google Spanner, but like you can actually do something incredibly similar to that with like a Raspberry Pi and like a $20 GPS receiver. And that doesn't take Google level engineering resources to pull off. Like, the idea that this is just free for all humanity is phenomenal.
Yeah, it is nuts. I mean, yeah, well, why have I been so ungrateful for GPS? I feel like I've not given sufficient gratitude to GPS. You're really there's got to be a good book on this, on the history of GPS.
It's like the longitude, but for GPS.
Yeah, exactly.
Right.
Well, because
there is a book that I would recommend that's kind of adjacent to this, which is about the Iridium system, Iridium phones. It's called, it's got a fun name. It's called Eccentric Orbits. It's kind of like a business book about the drama around the invention of Iridium and all the drama around the bankruptcies, and then the US DoD bailing them out, and Motorola wanting to deorbit the whole constellation. That's really a great book.
Oh,
but it's interesting.
I can inject that into my veins. That sounds terrific.
It's interesting to hear you folks talk about GPS, though, because something which probably most people outside of the US might remember is something called selective availability, where there was two GPS signals. One was encrypted, and you had to have and it was actually pretty interesting how that ended. I think it was embarrassment of the US when not all US military could actually afford the encrypted GPS terminal. And so you had like families paying for commercial GPS that had reduced resolution.
And I feel like there were a bunch of tricks too that the commercial GPS was able to do to basically amp up their resolution.
If you needed to use GPS for something where you really needed high resolution and you were outside the US, you could actually correct that. And there was actually a whole network of they call differential GPS. So basically somebody goes and very accurately surveys a point on the planet somewhere, and then transmits a signal, a low data rate signal on a very low frequency, like shortwave type frequency, that is just basically saying, given the satellite, given the GPS coordinates you are seeing right now, apply this correction to the coordinate to get the actual position. So differential GPS used to be a thing. I don't think it is anymore.
The correction signals
differential
are still
GPS
a thing.
is definitely still a thing. Like, I know that with like COTS hardware, you are now able to get like 3mm resolution with stuff you can buy off like Adafruit.
Oh yeah, that's one of the final exam questions, or one of the required projects in the AFIT, the Air Force Institute of Technology's GPS class, is to draw art on a poster using differential GPS at the end of a robot arm. If you complete the poster, you get credit, but yeah, that was.
But if you don't, yeah.
Yeah,
okay.
yeah. So I still have that somewhere. That was fun.
Wow. And Bill, did you take this course? I took it.
Yes, I did. Yeah. So it
complete with ionospheric.
Oh yeah. We
Can I tell you a fun story about GPS?
Go.
Which is in self-driving cars, right? They're a thing. None of them actually use GPS to navigate. Like for the most part, the high-end self-driving cars use GPS to sort of roughly find out where they are, and then it's all LiDAR based after that, because GPS, as good as it is, cannot be counted on reliably enough.
And is that just because of you're just going to get, it's too easy to have that signal be blocked with foliage or a tunnel or
Sure. Weather, right? So it's like those
Weather,
correction signals, like when weather happens, they're okay, but the reflection problem is huge. So in the urban canyons, you get all these reflections off tall buildings. Very, very hard to reject all those reflections.
Well, I really, fortunately, my 17-year-old doesn't actually listen to this because, with the he would love to have a whole new bevy of excuses about how the locator on this phone was actually incorrect. In fact, no, Dad, that was an urban
canyon.
No, that's an urban canyon, Dad. That's an urban canyon. That's sorry. No, I was
in the library.
I was in the library. That's exactly right.
But to the original observation, GPS is totally amazing, and I agree with you. This is the fact that they give it away for free. It's awesome. It's so good.
Yeah, I mean, I guess it's kind of like hard to not give away at some level, right? I mean, I guess the nature of the problem means like, well, I guess we're going to have to give you some. I mean, I think did they kind of? Sorry, Matt, go ahead.
Well, they absolutely didn't have to, right? I mean, GPS was completely a military project from day one, right? And the fact that like someone had the foresight to see the civilian possibilities on it is just,
There is also
something
another.
We all have to be very grateful for.
There is another force, which is that other countries recognize that the U.S. military being able to turn off GPS at a moment's notice was an issue, and so there are alternatives, right? So your GPS receiver typically today has the ability to receive position information from Galileo. Is it called Galileo? So the European Union.
European one?
Yeah, and China has something called Baidu, and Japan I think both Japan and India have positioning satellites that are geostationary, if I'm not mistaken. So and then the Russians have one too. So there's like 4 odd constellations of something that is GPS or GPS equivalent.
But most of them are only location specific. I'm pretty sure the American GPS is the only constellation that covers the whole Earth.
I think
Maybe
the European
GLONASS too.
The European, the Russian, and GPS. So I think there's 3 that are global because they're all medium or low Earth orbit.
Yeah, I think the Russian GLONASS covers the whole Earth.
Yeah, I thought the European one was optimized for use in Europe only, where there's a lot of satellites in the sky, but at any given time, there's only enough to navigate over Europe necessarily, and anything else you get by accident.
All right, so
citation needed.
Yeah, there you go. Right. Okay, so I do want to keep Adam from getting into too much trouble especially with his 4-year-old. But I want to make sure that everyone got a chance to kind of chime in here. So I think Bill and Rick, and then Bart's the man. What are you thankful for?
Oh, I also want to give a quick shout out to the Salient Logic Analyzer, but the thing I'm really thankful for is grep.
the workhorse.
Yeah,
Yep,
especially whenever. Go ahead.
Use that every day for sure.
Yeah, especially whenever, due to decisions that were made before I joined the place where I work at now, we use Bitbucket, and Bitbucket search is less than functional.
You can make up for a lot of gaps with grep. Grep is definitely the workhorse. One of those things you run every day, and you're it's like awk, right? Got to be. Although actually, I learned from a kid actually a mother of a kid in the neighborhood who apparently like watched my talks online and asked for the awk programming language book for Christmas last year. And yeah, I like. Am I corrupting the youth, or am I edgy? I actually don't know. Like, I got mixed feelings on this. I kind of feel like, you know, if you're reading the classics, you know. Rick, did you want to chime in here? Rick and Bill, yeah. Go ahead.
There's so many options, but lately it's been a lot of Ghidra. I mean, for all the things that the NSA does, Ghidra is like one of the few things that seems to have paid off really well for, you know, a very useful tool.
Yeah, I really need to ramp on Ghidra. You know, watching other folks at Oxide use it. I mean, watching Cliff use it. I mean, Adam, have you used it at all?
No. I was hoping Rick, you could. I have no idea what it is.
Oh, you don't know what it is? Oh,
So
goodness.
clue me in.
Oh, yeah. Rick should tell you what it is. No, it's really quite remarkable.
So Ghidra is a tool similar in concept to IDA, which is the interactive disassembler. But basically the idea is it's reverse engineering software. So it is a suite of, you can load up an executable binary. It will reconstruct control flow. It will, you know, collect all the debug information and symbol information, and then not only give you disassembly, but also give you a decompilation. And so you can take an unknown binary that you found and dig into it quite deeply and understand what functions are called from where, and, you know, all the data references and things like that.
Yeah, this sounds awesome and right up my alley. Actually, I recognize this name because I was searching for a book on WebAssembly this weekend, and this in the public library, because that's what I do. And this book on Ghidra kept on coming up, and I was like, well, I don't care about that thing. Turns out I'm gonna take out that book from the library today.
You should. It is the second and ultimate coming of libdis, Adam. This is it.
Yeah.
It's good stuff. All right, yeah, Bill. Yeah. What do you got?
Well, I've got two things I'm thankful for, which kind of segue from one into the other. If I had to trace any particular open source library I'm most thankful for, it would be FFTW, fastest Fourier transform in the West. Started most of my I've got a physics degree, wound up doing a lot of signal processing for embedded radio receivers and instrumentation stuff. And then wound up, you know, having to use that to, you know, it's like, you know, looking at numbers is one thing, but if you're trying to go from numbers to a picture or a graph, you know, time to bust out the other workhorse and pipe something to GNUplot.
Oh, amen. Oof.
Because oh my God, you know, if you know, to quote some YouTube video about GNUplot from this crazy guy, you ever wonder what's going on with a piece of hardware? Well, so are we. Yeah, you know, by the way, watching that on the video wall at work was amazing, and all my coworkers, you know, just like started, yeah. But, you know, GNUplot, you know, lets me like take, you know, I was able to take time series data from radio signals and instruments and make sense of it. And then one day, you know, I get told the file server keeps on, you know, locking up for no apparent reason, and our admins can't make sense of it. And I'm thinking, why are they talking to me? I'm a physicist. I have to look at time series. I need to instrument things. And oh, wait, there's dtrace. Let's instrument the Solaris file server and solve a 12-month long, 12-month recurring problem by managing to figure out that it's 3 particular workstations running a cron job.
Oh, man.
I only had this because they had 18 months of log data that they had been trying to do that. And I'm like, okay, I looked at it as a signal processing problem, visualized it with GNU-Plot. And from that, they're like, oh yeah, you're a sysadmin now. And I'm like, wait, what just happened here?
One of us.
You've been deputized.
Does that mean I'm not the only person to have ever debugged a systems issue with the FFT? We are not alone.
At a previous employer, I tracked down a break in fiber between campus buildings using the signal generator and an oscilloscope to do time distance reflectometry because my boss was too cheap to pay an outside contractor to do that. So
that's
yeah,
a story.
I mean,
I feel that and FFTs are so. I was actually taught an FFT as part of the computer science curriculum. But
yeah.
And Adam, I don't know if you read the same. So Phil, we shared a professor. So Phil Klein taught us FFTs, and we were all like, "Well, this is extremely interesting, but what is this useful for?" And Phil is a theoretician, and he's like, "I don't know." Well, exactly. So yeah, I mean, so no, don't worry. You're having the same reaction that my engineer roommate had. I'm like, hey, can you tell me what an FFT is for? Because our CS prof says, he's like, I don't know, it's these for something. He's like, no, stop. Okay, let me go explain all of the uses of an FFT and why this is truly God's gift to be able to go from the time domain to the frequency domain.
Yeah. I mean, it's amazing. When we took signal processing for physicists, one of our final problems was write a 16-bin FFT from scratch. Show your work. Okay, moving on. But between going from FFTW and all the various libraries that have popped up since, GNU-Plot, and then later having pivoted into Python and Matplotlib, and Python and Seaborn, and now Python and now all the visualization libraries that are everywhere. I can't throw a rock without hitting a visualization library. But I'm just, I'm thankful that everywhere I look, there's always something that hits my sense of wonder. And that's the thing I love about working in this industry. There's always a rabbit hole to go down.
There's always a rabbit hole to go down. That is a great note to end on. I think that because the wonder, I think that anyone who becomes kind of is trying to kind of find the joy. It's like you got to find the wonder in the fact that all this stuff works is amazing. The fact that we got that GPS and whether it's Ethernet or CUDA or FFTs or so many of these technologies are just the absolute unsung heroes, and they are marvels. So that is a great note to end on. Adam, any?
Brian, this is a great topic. I almost hesitate to bring it up, but my piece of proprietary software is Microsoft Excel, but it actually dovetails very well with what Bill was saying about being able to observe and analyze data simply. I don't know if an open source alternative to Excel, but this is.
There are few things you love as much as SQL, but
it's true. It's true.
I mean, if you had to choose, I mean, they're right up there.
Yeah, spreadsheets are great, but this has been an awesome session. And Brian, again, great topic, very timely, and a lot of good things to go check out.
A lot of good things, and hey, happy Thanksgiving, everyone! A lot to be grateful for, and hope you and your families are well. And we'll talk to you next week.
See you next week.
Thanks everyone.